Hello, everyone. Welcome to today's webinar on the topic of preparing smart machines for the EU Cyber Resilience Act and Physical AI. My name is Knut Lasselüt. I run the IoT Analytics team and will be presenting part of the webinar today. And today with me on the call are Justina, who is my colleague here at IoT Analytics. Justina, can you advance the slides, please?
Yeah.
Justina looks after, for example, regulation and Cyber Resilience Act. And then today we have two great guests from AWS, Dimitrios, who is the worldwide lead for smart machines, and Ralph, who is a principal go-to-market specialist for IoT. We have a few things to cover. As IoT Analytics, if you don't know us that well, we are a market analyst, market research company. We do a lot of market intelligence in the space around industrial technology and specifically also machinery and AI. We've published a number of reports recently on these topics, such as the ones that you can see here on the left, and work with a number of companies in this space to help understand what's going on in terms of market movements around industrial technology. AWS, we have lots of touch points throughout the year also with AWS being the biggest cloud provider there is. And AWS has also published guidance on EU Cyber Resilience Act and on Physical AI. And you will see a little bit more later in terms of how they work with customers on this topic. Good. So let's get started. It's a 1-hour session. It's recorded. You will see the you will get the recording afterwards. And before we go into those two topics of today, which is the Cyber Resilience Act and the topic of Physical AI from a machinery point of view, I want to go through a little bit of on the top, like what is actually happening in the machinery space right now. So first of all, when we look at the machinery industry, it is a very, very broad industry. There are all kinds of machinery, from moving agriculture machinery, as you see here on the left, to construction machinery, but then also CNC machinery, packaging machinery, pharmaceutical machinery. There's a lot of different machinery types. They have a few things in common, and they're very different also when I talk to them. Generally speaking, the machinery market is about 3.7 trillion in terms of what it outputs every year. China is by far the biggest producer of machinery at this point, followed by the US and Germany. And the market itself, the stat that you see here on the right-hand side is from the German Machinery Association. And the market itself has been pretty challenging for the average machinery company because 2025, I think, was actually a slight downturn for machinery. And nonetheless, there's a lot of innovation in the market. The companies I put here on the left are among the leading companies, not only in their space, but also when it comes to digital and AI. We've covered all of them in some kind of case studies and had chats and understand there's quite a lot of innovation going on with these. And if you go to the next slide, when we talk to these companies, we hear a lot of things, but we do hear 6 typical challenges that come up again and again. And so the first challenge that we talk about or hear from them is knowledge loss is becoming a topic. And so some companies, for example, say they hired a lot in the 80s and 90s. Those people are retiring now, and that's a huge part of their workforce, and a lot of knowledge is leaving with it. Another people topic is general workforce scarcity. Here's an example from a shoe company, machinery manufacturer that says, hey, we just don't have the people who can actually maintain and service our machines. A third topic is the topic of being faster to market. Here's an example from Bosch that talk about that they really have to be faster at producing cars or components of a car. The fourth topic, specifically with European companies that I've had a lot of discussion with, is competing with China and the fact that Chinese companies have come to market with very high quality products at very low prices. Then there's the topic of protecting the data and staying secure. Some machinery companies go as far as saying that nobody wants to actually share information outside of their premises and towards the cloud, and that this is actually really a hindrance for innovation. And then lastly, this has been really a topic for the last year. We are starting to have these discussions about regulation, and specifically Cyber Resilience Act, and to some degree also NIS2 and EU Data Act, but Cyber Resilience Act really is the big thing. And as we think about, so we'll talk about those two things today. The other thing that we do a lot of surveys, and we also look at, hey, what are the different priorities? So we just talked about the challenges. Challenges often become priorities, but they're not exactly the same thing. Top priority from our point of view right now is operational costs based on our surveys, also visibility, and driving innovation. Now the issue, and you see this here in the quote that I put on the right, is machinery industries are quite different. And the quote here on the right is from a semiconductor equipment company. And they say, well, cost is also important for us, but it's much, much more important for us right now to be quicker to market and responsive to our customers, given that in that space, for example, right now, there's a huge dynamic going on with AI as producing AI chips. Good. And with that, we can go to the next section. I would hand over to Justina to talk about the Cyber Resilience Act, and I will come back later to talk about physical AI.
Thank you, Knut. Hello, everyone. So before we dive in the Cyber Resilience Act topic, just 1 second. Well, this happened. I'm so sorry. Knut, do you think you can please help me with sharing the screen? Or I can...
Absolutely. Give me 1 second.
Sure. Perfect. Thank you very much. So just to give a brief context about regulations, because this has been a super important topic over the past years, like there are a couple of reasons why this is happening. So first of all, the volume of regulation is increasing a lot. Over the past years, the EU has adopted a huge amount of legislative acts. Second, we're talking about compliance costs that are raising, which is basically a natural consequence of the huge amount of regulations. And third, we're also seeing that regulations are basically becoming a geopolitical topic. And we have 2 very big examples, which are the Russian-Ukrainian war and also how the US tariff act impacted the US trade economy. Now, moving on to the Cyber Resilience Act. So basically, I want to give you a quick overview before diving into what machine builders need to do and what are some of the most important deadlines. So the act is set to be enforced on December 11, 2027. In terms of penalties, CRA, I think along with NIS2, has some of the highest financial penalties, both absolute and percentage-based fines, like ranging from 15 million euros to at least 2.5% of a company's revenue. And when it comes to key provisions, I just want to highlight a couple of them. So first and foremost, basically manufacturers must design, produce, and develop products with digital elements with the integrated security measures. Second, the CE marking will become mandatory for products with digital elements. Now, think of this CE marking as a symbol, potentially a QR code that will be placed on the product, and without it, the product cannot be sold on the EU. Third, there will be tight incident reporting deadlines, which we will deep dive in a bit. Then also the CRA classifies products with digital elements as general, important, and critical, which is very important because it also imposes a conformity assessment or like a product audit that varies by product level. So manufacturers can conduct a self-assessment for important products in class 1, and for critical products, a third-party conformity assessment will be required. Now, moving on to the next slide, I just want to show you a bit the CRA obligations. So basically here, obligations extend across the entire supply chain, with manufacturers carrying the primarily compliance burden, as we can also see on the table. We're talking about conducting conformity assessment, creating and maintaining documentation, providing safety instructions. But now, what does this mean for machine builders? So first of all, machine builders have the responsibility of verifying the compliance of each product with digital elements that is part of their machine. However, so second point is that compliant parts, unfortunately, do not equal a compliant machine. So even if all your product with digital elements are compliant, you will still need an additional compliance for the overall machine. Now, let's talk a bit about what's coming next. So the first deadline, which actually passed, is that machine builders now can get their products with digital elements certified by an official conformity assessment body. This deadline was on June 11, 2026. The second important deadline is on 11th of September this year, when machine builders basically will need to have a reporting process in place for severe incidents and actively exploited vulnerabilities. And the last deadline is actually the final one on December 2027, when machine builders will need full CRA compliant machines for the EU sales. Now, let's have a look a bit at the first deadline that just passed. So basically, what is a conformity assessment body? This is an independent body. Think of it as an institution that is designated by an EU member state, and it's responsible with conducting these third-party risk assessments. So, and here we have 3 deadlines. So the first one is that starting now with June 11, member states can begin designating these conformity assessment bodies. Then by December 2026, there needs to be a sufficient number of bodies so as not to create a bottleneck when the final deadline on December 2027 takes place. Now, just to show you a quick example, so in order for you as a machine builder to check to which conformity assessment body you have to go, you will basically have to check the EU register for designated conformity assessment bodies. So it's called NANDO, and there you can search by country or by legislation. And at the moment, there are no conformity assessment bodies designated, but that's basically the spot to go. Now, moving on to the second deadline, which is that machine builders will need to have a reporting process in place. Now, the CRA basically defines 2 categories of events that require notification. We have mandatory ones, where we're talking about severe incidents and actively exploited vulnerabilities. And for voluntary ones, we have another 4 category of events, which are basically any vulnerability, any incident, any misses, and any cyber threats that could impact your product. Now, CRA imposes a 3-stage reporting pipeline. So, first of all, manufacturers must submit an early warning 24 hours of the moment of being aware that a severe incident or an actively exploited vulnerability happened. So it's very important to know that this deadline starts running from the moment of awareness and not certainty. So manufacturers or companies should not wait for forensic audits to be conducted. Then the second deadline is a detailed assessment that needs to be provided 72 hours after the manufacturer is aware. So again, an awareness deadline. And the last incident is a final report that needs to be submitted after taking a corrective measure to remediate the situation. And here the deadline varies. We're talking either 14 days or 1 month, depending on whether it's severe incidents or actively exploited vulnerabilities. And now, these incidents will basically be reported on the single reporting platform, which is an electronic platform that ENISA, the European Cybersecurity Institution, has been tasked to create. And the platform is set to be operational by September 11, 2026. And also machine builders, manufacturers should actually expect a testing trial period before the platform goes live. Now, there are 6 things basically that machine builders should start doing now so they are prepared for the final deadline, which is December 2027. So first of all, you need to start your CRA cybersecurity risk assessment. We will just talk a bit about each and every one of them. Then second, machine builders need to ensure that each product with digital elements has an SBOM for product documentation. Third, machine builders need to seek early compliance with other security certification like IEC standards or EUCC certificates. Fourth, machine builders need to start managing security updates across the product or the machine lifecycle. And they need to start redesigning their existing products for compliance, and they need to be careful to build new machines on secure by design platform foundation. Now, I just want to mention a couple of words for each of these actions. So, for example, for the first one, machine builders need to start their security risk assessment. Basically, what they need to do is that you need to write a security target, which is a document that says that my product does X, Y, Z, and it's protected against ABC, and this is how I tested it. And after that, basically, who checks your security target? And we have 2 situations. If we're talking about important products in class 1, this is up to the manufacturer or to the machine builder, right? You're the one who reviews the paper. You're the one who signs a declaration of conformity. You don't need to involve a conformity assessment body, and the costs are basically internal. Now, the second case is for class 2. So in this case, the same machine builder writes the security target. However, it needs to be submitted for testing and for checkup to one of those conformity assessment bodies that I mentioned before. And these are the ones that are causing some troubles because they can be quite costly and they can take quite some time. Now, the second thing is that machine builders, they can't report a vulnerability if they do not know what's inside their machine. And now SBOMs basically are becoming off-the-shelf decisions. So you have a variety of solutions out there. We see there an example that on the AWS marketplace, there are nearly 300 SBOM solutions that can help you with CRA compliance. But the real work is actually integrating this output into engineering and customer-facing compliance workflows. And there you can also see on the slide an example of Red Hat and how they report and their SBOM for their products. Now, the third thing is to seek external cybersecurity certifications as a CRA bridge. Now, I'm saying this because, first of all, the CRA has a compliance presumptions for all the products that have been previously certified under a European cybersecurity certification scheme. And what I'm trying to say is that the CRA is not trying to reinvent the wheel here. Like these provisions already exist in other IEC standards. The difference is, and now they're making it very mandatory and you cannot sell your products and there are no loopholes. And we can see there a couple of examples from Bosch, who is pursuing an IEC certificate, from Pils, who's pursuing the same thing, and also from Festo. And the next thing is to manage security updates across the machine lifecycle. And here I'm showing you an example from Krones that updated their operating platform with a connect and secure feature to manage machine security updates. So this one basically supports software updates and connected security for machines, replacing more manual workloads, for example, by USB stick. Then we have redesigning products with digital elements for compliance. And here I wanted to show you an example of an alternative current charging controller from Phoenix Contact, which I think was released in 2021, and it had no firmware signing. It was quite standard for the area since security requirements were not that big. But then the trigger was actually the Radio Equipment Directive and also the CRA, which was slowly was adopted, but still with a couple of years until enforced. And I think, yes, that's perfect. Thank you. So in 2025, Phoenix Contact released an updated version and redesigned the product with embedded security, with SBOM monitoring, CSV databases, and physical protection of sensitive data. And now the last example that I wanted to show you was basically that machine builders need to build new machines on secure by design platform foundations to make their lives easier. And I took here as an example the Bosch Rexroth Control X OS. So basically the platform is IEC certified, and the apps and third-party extensions run on the same security baseline. And what this means basically for machine builders is that now they have passwords enforced by default. They have security patches, firewalls, VPNs, and there on the slide, I also have examples of two machine builders. We have Wolf and BFR systems. Thank you very much. And now I will handle it to Ralph for the AWS perspective.
Perfect. Thank you so much, Justina. And as a follow-up, I'll be speaking in the next few moments about how AWS is helping customers to implement the requirements for the EU Cyber Resiliency Act. And over the last 10 years, AWS has been supporting many 10,000 customers in this space, connecting billions of devices and exchanging trillions of messages in many different industries. And these range from connected cars to connected consumer goods, but also to the machinery. And today's webinar is all about the smart machine space. So I thought I'd bring 3 examples along where we have helped these companies to connect their special machinery and equipment. Kone is using AWS IoT services to connect over 500,000 elevators and escalators worldwide, growing to reach 1.6 million devices, enabling predictive maintenance that reduce customer-reported issues and entrapments by 40%. Or Heidelberger Druckmaschinen connects more than 15,000 machineries standing with their customers globally to their cloud, leveraging IoT for predictive monitoring to maximize machine uptime and also reducing troubleshooting and shooting this remotely through digital services. Or Kraus Maffei, and that is a very special one. They built their social production platform, digital production platform on AWS in the cloud to help the plastic processor real-time monitoring for their injection molding machinery, including process analytics, condition monitoring, and a chat interface that has an alerting capability for the operator. So it is a team member to the operations team. So this is only just a quick example. Now, before we dive into the EU Cyber Resiliency Act and how we help, let me give you a little bit of an understanding of how AWS thinks about security. And we have 4 key principles. First, security is our top priority. We call it job zero. Everything else comes after security. Second, security is everyone's responsibility, not just the security teams. Every engineer, every product manager, and every salesperson has a role in security. Third, we believe in guardrails, not in gates. Very important so, because we want to drive innovation. We enable innovation by providing security boundaries rather than blocking progress. And fourth, security is a journey, right? It's not a destination. It requires continuous improvement. It requires continuous adaptation, and it requires a continuous remaining agility to remain on top. And these principles have guided how we have built our services and they align perfectly with the Cyber Resiliency Act secure by design philosophy. So when customers adopt AWS services, they're not just buying technology, they're also getting security first mindset embedded in the services. Now, let's look into how we are actually accelerating the compliancy journey through capabilities. And there are 5 key capabilities. First, identity and access management provides fine-grained control with multi-factor authentication and least privilege principles. So every device, every user, every service can have precisely the access it needs and nothing more. Second, end-to-end encryption provides comprehensive data protection across cloud storage and transmission points. Data is encrypted at rest and in transit. Third, immutable audit trails, a requirement that you have heard from Justina. It provides tamper-proof logging for investigation and compliance verification. Once logged, events cannot be altered or deleted. And fourth, an automated compliance reporting enables real-time evidence collection and documentation for regulatory submission, a point which is important if you would want to think about a 24-hour workaround time. So instead of manually compiling reports, customers can generate these automatically. And last, we provide multi-region support, ready-made services that have been battle tested at scale. Customers don't need to build these capabilities from scratch. They can leverage services that AWS has refined over years, serving millions of customers. Now, what is important as well is it is critical, however, to understand the AWS shared responsibility model in the context of the CRA. And I invite you, if you haven't heard about this, please go and search the web. There is a lot of material. Security and compliancy is a shared responsibility between AWS and our customers. This shared model can help relieve customers' operational burden as AWS operates, manages, and controls the components from the host operating system and virtualization layer down to the physical security of the facilities in which the service operate. The customer assumes responsibility and management of the guest operating system, including updates and security patches, other associated application software, as well as the configuration of the AWS provided security group firewalls. So the nature of this shared responsibility also provides the flexibility for customers and controls. So once again, while we at AWS are responsible for the security of the cloud, protecting the infrastructure that runs all AWS services, this includes physical security, network infrastructure, and hypervisory layer, the customer is still responsible for the security in the cloud. And the responsibility is determined by the service that you use. So for companies affected by the EU Cyber Resiliency Act, this means you remain responsible for device security, application security, identity and access management, and data encryption. AWS services are designed to make achieving compliance significantly easier and more cost-effective. And I would like to also highlight, because that was talked from Justina just before, we are not an attestation body like TÜV, SGS, the British Standard Institute, and the ones that you have in the local market. Now, what are the services needed for the EU Cyber Resiliency Act requirements, and how do you accomplish actually this through the AWS services? Let's dive into this. Let me map this requirement. We heard about the security by design principles. First, security and identity manages authentication and authorization and certificate management. Secured by design and secure by default requires to think about and implement mechanisms and processes on how to bring security through secure modules and certificates into your products and services right from the production start. Second, device connectivity and management handles how devices connect to the cloud and receive updates. To execute software updates and patch management, managing and updating and monitoring your entities, be it a connected device or software component, is at the center of this functional execution. Third, establishing a robust vulnerability management, like we have heard before, requires a strong foundation for monitoring and detecting, which means you need to continuously stay vigilant, watch for security threats and vulnerabilities. Fourth, event processing and automation responds to the security events and automates remediation. So in case there is a security attack, you need to automate your response, and you need to respond immediately by quarantining your attacked entities or by executing required steps to remediate security and report on this event. And fifth, long-term evidence persistence. Very important, which stores compliance evidence for the required retention periods. Now, this architecture integrates with the 4 external entities: an OEM on-premise manufacturing system, a security operations center, teams that continuously monitor security, the authorities like heard before, ENISA or CSRT, and the product cybersecurity partners that integrate for the SBOM. And this isn't just a theoretical exercise here. I'd like to invite you to take a snapshot on the QR code that you see in the right bottom corner. I'm not going to go into the details of this slide right now, but you see here, these are the managed services that I mentioned before that help us to help customers to comply with the EU Cybersecurity Resiliency Act. For instance, we provide AWS IT Core for connecting devices and keeping them secure through authentication authorization, AWS IT Device Management for updating devices, or Device Defender for monitoring devices, CloudWatch, Amazon CloudWatch to provide the update in regards of logging details, and AWS Lambda or Amazon SNS to support the implementation for the EU Cybersecurity Resiliency Act. And there's certainly also the integration towards the partners. Now, let's speak about how we recommend you execute your EU Cybersecurity Resiliency Act journey. Step 1, assess your current posture. We recommend that companies who are obligated to comply with the EU Cybersecurity Resiliency Act conduct a gap analysis between the existing infrastructure, cloud security infrastructure and controls, and the EU Cybersecurity Resiliency Act requirements, with the consequence to identify high-risk areas and map current assets. Second, we recommend to work on implementing monitoring. This step is about to deploy continuous vulnerability scanning and threat detection, and to establish a security baseline for normal device behavior or entity behavior to configure automated alerts for deviation. Third, we recommend to automate the response to be fast and adhere to the timeline companies have to go about. If you think about the 24 hours, the automation in regards to reporting, that can't be sort of manual at the end of the day. There shouldn't be any manual intervention. So this is all about automation in regards of the reporting. And the fourth one is about documenting the compliancy and generating the evidence packages and preparing that for the regulatory audits, and maintain a compliance dashboard that provides real-time visibility. Now, in this journey, and I'll shortly then hand back over to Knut, the AWS approach to security rests on the 3 pillars. First, we provide the most secure infrastructure in the cloud industry. We've invested billions in physical security, network security, and operational security. Second, we provide security automation that drives speed and agility. Let me advance this here, sorry for that. Is otherwise slowing down actually innovation. We would want to turn this around. We would want to enable this with confidence, reducing risk. And lastly, third, we're providing end-to-end security and guidance. We don't just give you tools, we provide best practices, reference architectures, and expert guidance like we do today through also the reference guidance. And yes, we do have a large network of partners that has already been mentioned by Justina. And with this one, I come to my last overview that I'd like to share. If you are a customer of AWS and already have built on AWS, here's a QR code down on the bottom on the left side. Run a well-architected review, which is a mechanism that you can adhere to the best practices that we recommend to build and use services. Here's one with the IoT lens. This provides a structured assessment and recommendation, and you can store all your results even through the cloud, through the console. If you are looking into the EU Cyber Resiliency Act, we are sharing here a best practices, the proposed architecture that I've walked you through. This is a reference guidance which is available in the on the net, and Justina also shared this. Please take this QR code here. And if you think it is quite a timely exercise that we need to do and get acting on, there's also partners that we provide. I've referenced once again towards the marketplace here with this QR code. Justina talked about the technology part, but there's also system integration partners that we can refer you to, and you can rely on that as they bring back the entire background in regards of running a gap analysis and helping you to implement the requirements to help you comply with for the EU Cyber Resiliency Act. And with this one, let me hand back to Knut.
Thank you very much, Ralph. Thank you very much, Justina. I think this is I would just want to add one thing for me, covering industrial technology markets for the last 15 years. I've never had a regulation topic come so high up in my discussions. And I think a lot of companies are really asking themselves, what do I need by end of 2027 at the latest? And I'm curious if we will see any big news articles of companies pulling out of the EU market because they're not ready, or big fines or whatever. I want to switch gears now. We're going to be talking about physical AI, a very different topic, but from a machinery company point of view, on a priority and challenges point of view, similarly important and interesting. I also see we've already had some questions in the Q&A, so please keep going, ask questions. We'll try to get back to this before the end of the webinar. So let's quickly talk about physical AI. This is a topic that even more than Cyber Resilience Act has come in the last year. And why is that so? Because the CEO of the biggest company in the world right now basically has said, you know, forget about Gen AI. Now we're talking about Gentic AI, but really the next big thing is physical AI, and it's an even bigger opportunity. And what is physical AI for Jensen Huang? He says this is where the largest industries of the world are going to benefit, and requires us to understand things like the laws of physics, friction, inertia. And he had an example, I think, on this stage where he had a bottle and said, if this bottle falls down, the AI needs to understand what that means, and it's not out of the picture. It actually needs to understand the laws of gravity and those things. And that really probably marks one of the biggest interesting challenges in technology movements that we're going to see in the next decade, I believe. And consequently, you know, we always look for market signals. These are very strong market signals, easy signals to monitor. On the left-hand side, a Google search graph. On the right-hand side, what the CEOs discuss in their earnings calls. And you can see starting in about November last year, so less than 9 months ago, this topic started to take off. And you suddenly have a lot of companies here, for example, Qualcomm, talking about how physical AI is becoming a priority for them and their product portfolio and so on. And so I get a lot of questions, what is actually physical AI? And I will be perfectly honest, I don't think I have the perfect definition yet. And I also think there are different movements in physical AI. So first, physical AI is an AI that perceives, understands, and reasons, and very importantly, then acts on that in the physical world with some kind of action. But that's a very vague terminology. And in the most and there are different types of physical AI, I find. Yeah? In the strictest sense, people are saying, well, the embodied physical AI, think of humanoid robots. In a little bit less stricter sense, just generally the robotic physical AI. There are people who say, well, really it's about autonomous machines. That includes autonomous cars, but also other autonomous machines. You could think of it further and say, well, AI-enhanced machines, as long as AI kind of triggers an action, is also physical AI. And then there are people who say, well, any actuator, anything that acts in the physical world and has some kind of AI connection is physical AI. So I think of these kind of 5 different types of physical AI, kind of strict or not so strict. And for the purpose of this webinar, I think we are somewhere between scenario 3 and 4 as we talk about physical AI. We're not going to be talking about robotics only, although it does play a role. And I do want to talk about robotics quickly because we as a market research company monitor robotics market, and we have been for a while. And what we're now seeing is that suddenly in every discussion that we have, it's becoming very apparent that the robotics market is at an inflection point where driven by humanoid, quadruped, but also mobile robots, this market is kind of going to see an inflection going up. And we have lots of data points where we talk to people about the fact that they are really seeing their order books filling up with AI-based products in the robotics space, or that they're talking about the customers who have a non-automated workshop or whatever they have, and suddenly start to think of putting a robot or something in there. So that's a good example of how physical AI, from a market point of view, there is a market being created in the robotics side of physical AI. There are other markets with physical AI. We're not tracking that yet, I would say, but I did want to share this because I think I'll give you some examples. What I think is actually fascinating in the robotics space. This is an example I saw 2 weeks ago from a startup, California-based startup called Generalist. And what you see here is 2 cobots from Universal Robots. And typically you would program a robot, but here, and unfortunately, you may not see this individually, but this is a box that you need to fold in very carefully. And the example was fascinating because these 2 cobot arms were able to just pick a box, fold it together, put something in, fold the other side. And this was by no means a repetitive process. Quite the difference. If you take it away, it would come after you and try to grab it. And so this is kind of some new foundation model for robots that is coming in with some of these companies. This company says with a robot brain, and we can work with any kind of robot. And that's the kind of paradigm shift that you see in possible, where before you were programming things, suddenly you can tell a robot what to do and it'll find a way to do it. For machine builders, I think of this as there's 3 main opportunities with physical AI from my point of view. First of all, you can think of smarter machine operation. Vision plays a big role, anomaly detection, and then acting on that. The second thing is having higher machine autonomy. So having some kind of autonomous loading or unloading, for example, or some automated closed loop decision making. And then I think as a machinery company in specific spaces, you want to think of new machine categories where you have some autonomous equipment. I think Dimitrios might share one here in a minute. And I think that's how I think about it. Here are a couple of examples I've come across in my research. Here's a company, Mazak, which is a CNC, one of the leading CNC machinery companies, has a product, and they've had it for a couple of years already, called Smooth AI Spindle. So the spindle in the CNC machine turns very quickly, and they say they have various vibration sensors now installed in there, and they record the vibration and the chatter marks, and then accordingly an AI algorithm automatically increases or decreases the spindle speed, which is essentially a physical AI because the AI is acting autonomously on something in the physical space, in the machinery space. Here's another example from Krones. I talked to them a couple of months ago, and they have a new offering called ContiLoop, and it's an AI-based parameter optimization on their blow molding machine for PET bottles. And they say if the process degrades, for example, if the temperature changes, they have a trained AI agent sitting on the machine that then adjusts parameters, and it learns over time. So it's a reinforcement learning based concept on the machine, which I sounds quite interesting, I would say. And then lastly, here's an example where you actually have a robot in place. It's a PAC Machinery. It's a packaging machinery company. And this is a showcase together with Fanuc and a Korean-based company, CMAS. And what they show here is a setup for, in this case, Kupang, which is the Amazon of Korea. And what they show is that they can put anything in this bag that you see here, of any form factor, of whatever, with a cobot arm from Fanuc in this case, and they have an AI processor in here, in this case a Dell workstation, and a vision, and they can actually grab anything of any size, reason over how do I put that in the bag, and then and so on, and you really move away from this repetitive. And so here you're connecting a machine with a robot with AI capabilities. So there are a lot of more examples, but I do want to give the floor to Dimitrios, who would like to share the AWS perspective, and then I would love to get into some questions from the audience.
Yeah, thank you, Knut. Hi, everyone. Dimitrios Spiropoulos, leading the smart machines business for AWS. I will share with you the AWS perspective, what we see in the market, how we are approaching the physical AI capabilities for the machine builders or autonomous systems companies. And we'll share also some customer examples at the end. So before we go deeply on the physical AI, I want to first share with you how we see the journey of the machine builders while they are heading towards autonomy to solve some of the challenges that Knut shared at the beginning. So first is to do nothing, right? You just have your mechanical machines. I would say now many machine builders have moved to have the connected machines. This is a phase one that has been here for maybe 10 years, right? Add the connectivity, fleet management, insights only for the machine builders. The phase two is making the real smart machines where the functionality and security of the product can be updated throughout the life cycle of the product with over-the-air updates. The machine builders give insights and analytics and applications to the end users or to their dealers, and also machine learning capabilities, and also in the phase two. I'm still in phase two. We start seeing also the first Gen AI usage, let's say for assisted diagnosis, for maintenance and servicing, and with Gen AI also give troubleshooting recommendations. This is where we see, and many companies are here and trying to make it right at the phase two. And in parallel, we have the phase three, autonomous machines, where we see many customers are trying to achieve this phase, to be at this phase, not with everything that you see here, but starting with some of these capabilities. And we have also the startups that are building, I would say, autonomous native machines or systems. So in this phase three with autonomous machines, we can see capabilities around agentic workflows, like automating full workflows with agent orchestrators and many agents doing different tasks related to spare parts, customer support, servicing, and many more. We see video in general becoming a big theme in the machine builders more and more. And now with the visual language models and visual language action models, this becoming more interesting, I would say, and more useful for the machine builders and for their customers who can understand the full context. They can query the video, they can create more local or personalized rules. This is becoming very useful. And the teleoperations becoming even more important today, because it's useful to, let's say, to do the remote troubleshooting for the autonomous machines or train the machines beyond the classic teleoperation we had in the past. The intelligence that is not only in the cloud, coming at the edge, this is becoming very important, right? It's key proposition, I would say, for the autonomous machines. And the voice, another trend, voice interaction, voice command, it's more like human-machine collaboration and interaction through voice. Another concept that we see companies moving forward is about self-optimized machines, where it could be optimization for quality or for sustainability or maintenance. And then we have training and simulation now, with the physical AI becoming like a key pillar in these autonomous machines. And eventually, this machine builder are looking to build their autonomous operations. Like for construction, you'll see examples, or for agriculture or factories, bringing all these capabilities together. So it's a journey. It doesn't mean you need to do everything, but it's what is important for you and your customers. But these are the latest, I would say, version of the journey we see. And now let's talk about the AWS physical AI point of view. And here is a framework we have developed so to help customers and partners understand where AWS can help. So we're looking at the full tech stack of physical AI, and here we have put some categories and capabilities. If you see on the top left, there's the 01, which is around contextual data, how you are the machines can ingest data, multimodal data from telemetry, from video, from LiDAR, ingest it to the cloud, structure it, and trying then to do train the physical AI models, do the fine tuning or create the models in order to be able the machines to become more autonomous and intelligent. And then it's about the training and the simulation. Not everyone needs this or is using it, but we see many companies, we see huge momentum there, trying to simulate and combine real world data and synthetic data in order to perform what they need to do and improve. And then is how you are deploying the models back to the real world, and how you are validating these models are correct. And we have the number 4 with the green box at the left side with the edge operations, which is that the operation happening at the edge without the always on connectivity to the cloud. And this is where we have also the loop of the autonomy, where the machines are acting autonomously, as Knut shares some examples. And the training is happening in the cloud through synthetic and real world data. And we have in the center agentic orchestration, how to all coordinate all these through agents. And let's move the next. This is I will not go into the detail, don't worry, but I want to show you what does mean the previous tech stack for the smart machines company, like that they're building, the machine builders and the autonomous system startups. We have put the services together. You see on the edge, on the left side is the edge, the machines and the gateways, and then how you are collecting the data, video, or like with Kinesis video streams or IoT core for telemetry. Then you pass it to the data lake, and you can do the training with a SageMaker. You can do the simulation with AWS Bots, and also partners like NVIDIA working together, and then sending the data, the models back to the machine through AWS IoT Greengrass, and having even the device management service to manage it at scale when these companies have big fleet of autonomous machines. And the important is the full flywheel for continuous improvement and the data flywheel. We will share it probably with a follow-up with the email that you will see with the recording. We'll share probably a link with this technical guidance. You can read the step-by-step in more detail. And I would like to share a few customer stories before we go to the Q&A across different industries. So Neura Robotics, maybe a lighthouse company for humanoids from Europe. They signed a strategic collaboration with AWS to help AWS build for them the cloud training, and also their platform for Neuraverse platform, and also for the gyms, the training gyms that they have to train the robots. So this is huge collaboration among also other partners like Qualcomm and Zoe. Next one is from agriculture, another autonomous machine. Agriculture here is the machine from Terra Robotics, is the machine on the back of the tractor, the white machine, which is the autonomous laser weeding robot that you can put on the back of the tractors, and it's treating all the weeds without using any pesticide, any spray. And it has some great results already, like reducing the weeds by 92%, dealing with the labor shortages, that they can't find the people manually remove this. Also, that's related to regulations and the pesticides and all that. So it's very great example of using also AWS IoT services and SageMaker to make this machine work autonomously. Another is from the construction sector with Bedrock Robotics. Now this is not a machine, it's a system, autonomous system that you can put on top of excavators and make them autonomously. And the last example is from manufacturing, where another company from Europe, Robotwin, they're helping robotic arms learn from the humans to do the welding or the painting. And now they're working with AWS to build a fully autonomous system using, again, IoT and AI services from AWS. And then the last point is that we see Amazon, the fulfillment centers, and Amazon.com as the world's largest physical AI laboratory, with millions of robots deployed around the world, with over 2,500 facilities, and also almost close to 1 million autonomous fleets. So this is a huge, I would say, autonomous operation and physical AI lab that we're also learning from that. I think now it's time for Q&A. Hopefully it was useful.
Super. Thank you so much, Dimitrios. I know we had a packed webinar with two big topics. We received some questions, and I would say, I know we have 5 minutes left. We're happy to go a bit over and answer some of the questions for those who want to stay on. So I'll start with some Cyber Resilience Act question. The first one that came in was from Alessandro asking, being part of call 1 or call 2 involves significantly different levels of effort. So this is for the Cyber Resilience Act classification. Could you provide more information about the classification criteria? For example, in which category would a packaging machine or a food and beverage or pharmaceutical industry belong? Justina, can you take that?
Yes, sure. Thank you. So to answer, like with the classification with class 1 and 2, those are actually explicitly listed in the CRA. I think annexes 1 and 2, if I'm not mistaken. But with the question, like in what category would a packaging machine fit? Like I would say that for machine builders, the packaging machine itself would most of the time fit in the general category. The main challenge is the product with digital elements that actually go in it. So maybe, I don't know, and the operating system or an identity access management, these are explicitly listed under class 1, or maybe it's connected to some gateway and this is a critical product. So for example, you as a machine builder need to verify that all the other products with digital elements that you're integrating in your final product, that those are compliant. I think this is the main challenge when we're talking about packaging machines. Now, if you're also the manufacturer of these, if you also build these type of products, if you have your own operating systems, for example, like, I don't know, Bosch, then you need to focus more on those products, that are listed under class 1 and 2. So the final one would usually be under general. I hope that answers the question.
Thank you. And by the way, it would be super if you could give us 1 minute feedback on the webinar itself. I think my colleague will share a link in the chat. It doesn't take more than a minute. Just rate us. Just tell us what we can improve. We always look to improve. So I'll go on, and I will say for those who have to leave at the top of the hour, thank you for attending. If you have any follow-up questions, please be in touch. I think there was a lot shared, and we will send the recording with some additional information in the coming days to you. For those who want to stay on, we have a few more questions, and I would like to go through them. And again, please fill out the survey if you can. That would be super. Let's talk about this question that just came in. Physical AI is to be implemented through Edge AI. And the question is, where does the maturity of edge AI stand right now, specifically regarding visual language models or visual language action models for inference at the edge? Are we on the cusp of mass deployment, or is it still years away? So I'll quickly ask Dimitrios if you want to take it. I have an opinion, but I know you also see a lot of implementations, so maybe you also do.
Yeah, start and I will take it after you.
Okay, I should start. Good. I think we are on the cusp of mass deployment. I think first of all, when it comes to edge AI, and the systems have become really powerful, and it's not only NVIDIA. There's a number of companies who are kind of making these really powerful systems. And you know, I'm not a technical guy, so I don't know the exact how many tops and what is here. But what the edge vision language models that I've seen are extremely capable, and my discussions with companies are that you don't need to connect this to any bigger server at this point of time for some of the analysis. So, and by the way, and I'm from a market signals point of view, but discussing with both the chip companies as well as the system companies who make these edge AI systems, they are clearly seeing the ramp in demand for this.
Yeah, thank you, Knut. I agree with your perspective and what we also experience in the market. And just a great example is the Bedrock Robotics that I saw you for the construction. They are doing everything at the edge. We're using VLAs, and they are fine-tuning how to make brownfield excavators autonomous, not just to move around, but also do the task of excavation and digging, which is quite complex, and health and safety. So. And this happening with this approach. And yes, a collaboration, I would say also AWS with the semiconductor companies, special models, and bringing edge AI is done. And the cost has also been reduced, I would say, right, comparing with a few years ago. Of course, depends on the use case always, but yeah.
Thank you. Good, yeah. Another question that came in is, I'll stick to physical AI for now. What are the key technological challenges in physical AI implementation, and what solutions exist to address them? For instance, how can memory constraints be resolved through model quantization? And what are some real-world examples of successful quantization solutions? Dimitrios, this is very technical. I know we also have some technical specialists on the call. Is that something you want to take?
I don't have a valid opinion. This is more like machine learning and HPC solution architect, but maybe we can follow up. You can reach out to us and cover this question. But I would say in general, the technological challenges, like, of course, there are many, but I think these are progressing. Something that we hear in customers is which I think is surprising to say this, but it's the lack of connectivity everywhere. Like, even if you do everything at the edge, you really want to continually improve and have this kind of feedback loop, even after a few days and all that. So we see that this is becoming a bottleneck for scaling and taking the solution wherever they want for the continuous improvement. But of course, we have the Amazon Leo, and for AWS, this is kind of the answer, plus our other partners. But there are more challenges. But yeah, Knut, do you want maybe to share one more technological challenge you see?
In my head, I was already on the next question, so
okay. Let's go to the next.
I won't do that right now. I feel we have to give Ralph the floor here as well. Ralph, I don't know if you can answer this question from my friend Ian, who is asked if you see any CRA classification categories changing in the near future, since ENISA and the Council already has a separate categorization list that mentions critical infrastructure such as grid. Manufacturing should have heightened security levels. I don't know if you have have an opinion on this?
Yeah, no, for sure. I mean, let's sort of distinguish between the two. I mean, the EU Cyber Resiliency Act addresses more actually the security of a product, right? what has right now come through with this question, there is certainly the NIS2 regulatory that addresses more to the operator side of things, right? So to the utility companies, as an example, that provide gas and and are managing critical infrastructure. There is definitely another set of requirements, but not to confuse the audience, we have said we're focusing on one topic. I think probably, Knut, it's worthwhile maybe running as well a session on NIS2 as an example. I mean, that could also be an option if you want to think about that.
I personally feel that CRA has a higher impact in general with the people. So I think that today we have the bigger focus here. So that's I think that's good. We have one or two more questions, and then I think afterwards we can maybe wrap it up. One question again, I'm not 100% sure if anyone can answer it. Maybe Justina has a view. What is the percentage split of mobile OEMs and non-mobile manufacturers attempting to comply with CRA? And a follow-up question, how is this expected to change with physical AI? So here, someone in the audience is trying to actually get our two topics to come together, which is great. Do you ever have a view on mobile versus non-mobile equipment?
I don't have a precise number here, but if I look or consider back, the numbers, I think you published as well researches in regards of mobile connected devices. So I would assume mobile means here cellular-based connected devices.
I would have had a completely different interpretation, but yeah, I would have thought it's mobile machinery and non-mobile machinery, but that's
okay.
So the same. I thought the same, moving assets, right?
Yeah, true. Maybe we need to ask the gentleman or the person to maybe come through once again with a bit of a clarification. I would assume, this mobile enabled, there's a cellular technology, right, that integrates into the machinery, but there's also other means of connectivity standards, right? And I don't have any elevated sort of insights into this. I would assume that it follows actually the normal distribution, which means the tech stack, and I think you're publishing researches about this, Knut, right, and the team, that follows the exact precise distribution. So companies would probably follow up on this one in the same manner. That would be my reading from this, but happy to be... Maybe.
Yeah, I mean, we've seen for a few years now that cellular mobile solutions have outgrown other types of connectivity, and thus it's quite likely that mobile is increasing. And if you look at it from the other way around, mobile versus non-mobile equipment, if that was the question here, I don't actually think that makes a difference from a CRA point of view, because at the end of the day, as long as you have a kind of a requirement of this being I don't know how you exactly put it, Justina, but like a product that qualifies here.
From a category point of view, class product. Yeah. Mm-hmm.
Yeah. With physical AI, I mean, my expectation is that physical AI is really only possible, at least at the moment, with a decent connectivity. Like you can do physical AI just being offline, but I think you do want the capability to load something onto it and everything. And so as physical AI gets more bigger in the industry, I think the connectivity and the ability for these types of machines to be to have compute on it and everything is just going to go up. No, I don't have the exact implications from a CRA point of view on my.
And there is also the AI Act and the Data Act that I think whether physical AI is becoming even more relevant. But now we're going to a different topic. But I would say physical AI is even more interesting or complex the topic that needs even more attention than the non-AI or physical AI machines, right? Justina?
I'm sorry, it got a bit interrupted. Can you please repeat the last part?
I would say that just with the physical AI capable machines, it's becoming more complex because there is also the AI and the AI Act and the Data Act in Europe that is not just the CRA, it's like many more acts are coming together for this. With the machines that with the physical AI context, let's say, when these are autonomous machines, so it's even more interesting and more challenging and needs more attention, was my point.
It's basically like a cocktail of regulations. And what I always like to highlight when it comes to CRA is that if you're really lucky, you would only have to comply with CRA, which is fine. But in these cases, it's not only that, there are other big ones, like you mentioned, AI Act and Data Act. And once you add all three, now that's the part that's challenging, because one act itself, that one you can manage, but then you have to correlate everything.
Yeah, we have the guidances for all this, so it's how customers can bring this together, and they're the right partners, right? System integrators to help and guide the manufacturers. Thank you very much, Knut and Justina.
Thanks everyone for a great discussion, and thanks for sticking around for those who've went over the top of the hour. I hope you know where to find us. I think there was plenty of hints given in the presentation today. We'll be in touch anyways, and we always welcome your questions and your the exchange. Thanks, Justina. Thanks, Ralph. Thanks, Dimitrios. I look forward to continued exchange and exciting times ahead with compliance and the next level of physical AI.
Thank you.
Thank you, everyone.
Thank you.
Thanks for joining.
Thank you.
Bye.
Bye.